So I wanted to welcome everybody for this next installment of SU Teaches SU. We have a presenter, it's the second time presenting for us, Mr. Efrain Castillo. He's an instructor here at Southwest University where he teaches algebra and chemistry. He was born here in El Paso and he's lived in Juarez and El Paso his whole life. He graduated with a bachelor's in chemistry from UTEP in 2014 and went on to get his master's in chemistry from there also in 2016. During his graduate studies, he taught undergraduate organic chemistry labs, which is one of the tougher chemistries a lot of people struggle with. So this guy knows his chemistry for sure. He was a teacher's assistant. And after he graduated with his master's, he also taught chemistry labs at the Universidad Autónoma de Ciudad Juárez for a while before coming to teach here at Southwest University. Mr. Castillo has what I feel is one of the more unique hobbies, pastimes, endeavors. He's an avid archer, and he's not only an archer, but he teaches archery at EEDITA, which is an archery school in Juarez, and he's taught there for the past 3 years. I do know he's mentioned participating in several regional archery tournaments in Mexico over the past 2 years, and during quarantine, they actually did online tournaments, and he mentioned he's reached the podium in several of those. He mentioned 6 of them. He's also an active member of the Catholic community in Juarez. He sings for the Laudato Si choir, which serves Santuario de San Lorenzo, and they've served them for the past 10 years for the youth programs in the morning masses. But again, I mentioned Mr. Castillo teaches chemistry here at SU, and I know he always has a bunch of fun and exciting experiments. So we're actually joining him from home right now, where he's going to show us some of these experiments that students can do at home with their children, family members, whatever it might be. But thank you, Mr. Castillo, for taking the time and setting up these experiments at home to lead us through them. But I'll let you take over. But thank you again for joining us today.
Dr. Ramos, for that very warm and very nice introduction. Just at any time, just please let me know if I'm out of frame, since the cell phone is really, really far away, so I can't tell if I just get out of frame. So anybody or Dr. Ramos, you can let me know, right? If I just walk away and then don't come back, you can always let me know. Okay. So these are, we're gonna do 2 experiments today. They're really, really simple experiments. And I like this experiment because we can do those with pretty much whatever we have at home, okay? So maybe if you don't like sugar a lot, maybe you don't have sugar, but chances are everybody's gonna have some sugar at home. Everybody drinks from cans, right? I wanna say Coca-Cola, I wanna say Brisk, and there's no other kind of cans right around, or maybe, we don't know. Okay, so this first experiment that we're going to be doing, it's called the rock candy experiment, and I've done this, both of these experiments, I've done those with the general chemistry students, the MLTs, but now we just decided to share this kind of setup and experiments with everybody. So you can go ahead and do it with your kids, you can go ahead and do it at home, and it's really, really safe. It's as safe as cooking is, right? So of course you have to be careful with the warm stuff, with the hot stuff, don't leave the flame open and all of these kind of things, but as safe as cooking, okay? So I have a list of materials that you're gonna need for this experiment. And I'm gonna need 3 cups of sugar. I have 3 cups of sugar in here. And I'm gonna need 1 cup of water, okay? If you don't wanna do that much rock candy, then you can scale down the proportions or scale it up, right? Right now I'm using 3 half cups of sugar and 1 half cup of water, okay? But again, the proportions, as long as you keep the proportions good, everything should be fine. And I'm gonna put this sugar and this water into a preheated pan over here that I have been heating for the last maybe 5 minutes. I'm just gonna put the sugar in here. Okay, it looks like it's a lot of sugar. I'm gonna turn the heat on again. And I'm gonna start stirring this sugar into my water solution. So if you're doing it right now as I'm doing it, you're gonna see that most of the sugar is not going to dissolve right now. Okay, most of the sugar is just going to remain granulated in the solution or in the water. And as you heat up, all of the sugar is going to start dissolving in. Okay, so this is a property of matter. Okay, so when you add something into water and it doesn't dissolve, you can always heat it up to help it go into solution. And this happens, for example, when you eat a soup or a menudo plate, right? Everything's going to be dissolved very nicely, right, in the red soup. But if you put this in the fridge, if you lower the temperature, then you're gonna see all of these grease bubbles form in the top, right? Or you're gonna see a separation of layers in there. Okay, so the same is gonna happen with the sugar. Right now at cold temperature or room temperature, the sugar is not going to dissolve in the water. But as you heat it up and you stir it, you're gonna start seeing all of the sugar dissolve. Okay, so this process, it might take, well, it depends on the heat that you're going to provide to from your stove, right? If you have a very, very huge flame, things might be a little bit faster. Okay, mine is almost there. Okay, so what we're going to be doing is chemically, or what we can say chemically, is going to be a crystallization. Okay, and this is a purification process that's used in chemical labs, and it consists on putting something that's not soluble in water, well, putting water into something that is not soluble in water, and then heat it up until it dissolves. We're forcing it into solution, right, by adding the heat. And then we just let it cool down. And what happens is that all of the crystals or everything that you just dissolved in the water is going to come out of the water as well. Okay, but not the impurities, only whatever you have the most. So for example, if I have on this sugar, I have 99% sugar and 1% salt, then the only crystals that are gonna come out of the solution as rocks are going to be the sugar crystals. Okay, and these sugar crystals are going to be really, really, really pure. Okay, really, really pure. You can do analysis to these crystals and it's going to be 100% sugar. Okay, and then you can take these crystals and dissolve them in water again and do the same process all over and over. And the more you do this, the higher the purity and the higher the beauty that those crystals are going to be. So this is what we're going to be doing. Okay, so my sugar is already almost boiling in here. Okay, so you have to make sure that all of the sugar becomes pretty much a syrup. So once it becomes a syrup, we're going to move to the next step. Okay, while this sugar heats up, or while this sugar dissolves, we're going to prepare some skewers. So these are just regular skewers, and what I'm going to do is put a little bit of water on them and then rim them through the sugar. And that way I'm gonna have what we call a seed crystal, right? So we're gonna have several grains of sugar around the skewer. So that way, when I dip this skewer into the solution that I just prepared, the syrup of sugar and water, over time, the crystals are going to form on top of those small grains, right? So those grains are going to be seed crystals, and then everything's going to grow from there, okay? So in order to rim this, you can use the same syrup that you have already created, or you can use a little bit of water. I'm just gonna put a little bit of the syrup that I just created in here, and then I'm just gonna rim it through the little bit of sugar that I have over here. Okay, and what is this going to look like? I'm just gonna get closer to the camera so you guys see more or less how this looks like. Right now I have a little bit of sugar coating the skewer. This is going to work perfectly fine. I'm gonna do another one of this. These are going to be my seed crystals again, right? Seed crystals, so that everything grows from that part of the skewer. Get a little bit of the syrup. I'm gonna rim it through the sugar. Get off a little bit of the excess. Now I have two of these guys. Okay. Now that my sugar is completely dissolved, it looks like I have a little bit of wood in here from the spoon. Okay. My sugar is dissolved. I'm gonna get closer to the camera again, just to show you more or less how this is going to look like. Okay, hopefully I don't spill sugar all over the place. So that's just the syrup. Okay. That's the syrup. It's completely clear, and this is really, really important, that the syrup is completely clear, that you don't have any leftover sugar in there. If you have a little bit of leftover sugar, just heat up for maybe 5 more minutes. If it doesn't dissolve, just add very, very little extra water in there. Okay. So I'm going to take a glass. You can do a mason jar, or I mean, if it's a 300 ml container, that works perfectly. And what you're going to do, you're going to put the syrup in here, and then you're going to suspend these skewers on the glass without them touching the ground or the bottom of the glass. Okay. In order to do that, I will have to put the syrup here first. Then I'm going to take one of these clothespins. So you can use any tweezers, anything to hold on to the skewers, right? I like these ones because they are perfect hold. Okay. And what I'm going to do is once the syrup is in here, I'm going to try to get my hand out of the way. Suspended right in the middle of the glass, right? As you can see, this is not touching any of the corners of the glass. Well, since the glass is a cylinder, I don't think it has corners, right? But any of the edges of the glass. So this is how we're going to suspend this. And once we put this one in here, we don't want to move this ever again until we're ready to eat our rock candy. And I'm going to show you what this looks like. Okay. So the process sometimes takes about 2 hours, 3 hours. It might take 1 day, it might take 2 days. It all depends on the conditions. And if you just let it cool down and then stick it in the fridge later, it's a faster process. Okay. So I'm going to go ahead and put the syrup in here. The syrup that I just created. So I'm going to put this one in the table. So I don't want any warm sugar on me. Get this out of the way. Over there in the top. At this point, I forgot to mention, right? But if you want to add any food coloring or food flavoring, right? For example, I have here a grenadine sugar syrup. So there's already sugar in here and it's grenadine flavor. You can go ahead and add some of the flavor into the sugar that you use, or the syrup that you just have in there. And I'm just gonna stir really, really quick. So I should have done this over here on the pan. It makes no difference, right? You can add it at the end or you can add it at the beginning. Or you can add it to the water also, right? The water that you added into the pan at the beginning. And then you're gonna have some colorful crystals or flavored crystals, right? Depending if you add food coloring or flavoring. I wouldn't recommend you to add too much food coloring because it provides a weird taste, but you can always counter that with a little bit of food flavoring, like lemon or strawberry or green tea flavor, etc., etc. So now I have my syrup in here. This is where I'm gonna place my skewer, and you can place 1 or 2 as long as they're not touching each other and they're not touching the edges of the glass. And you're gonna do it really, really, really carefully. You just let it fall in there. And I'm gonna do the same thing with the second skewer. I have my second skewer. And the next thing that you have to do is wait, okay? So we will have to wait about 2 hours, 3 hours for these ones to be ready. But I have some already completed. I have been standing for about 48 hours already. Over here, I used tangerine syrup, right? So this is a little bit more orangey. And this is what it's gonna look like after a couple hours, right? I'm just gonna lift my skewer and you're gonna have this beautiful rock candy. Right, what is the flavor in here? This is tangerine. But of course, you can do any flavor that you want. Okay, let me see the other one. This one's a little bit better. So what you can do after you wait and you want to try this, I mean, this is 100% sugar. So as long as you're not diabetic, you can try as much as you want. But I will leave them soaking because they're soaking syrup. I'll leave them soaking in a paper towel, maybe 10 minutes, 15 minutes. And then you'll be able to admire the actual, the beautiful crystals in there. I think you can see it there, or the ones at the top. And this is going to be the rock candy experiment. It's really, really simple. It's really, really fun. You can mix up colors. You can mix up flavors as well. When I used to do this with the chemistry students here at Southwood University, they will come up with all of this weird combination of food coloring and flavoring. So I will have blue crystals that tasted like cherry. I will have red crystals that tasted like root beer. And then I'll have like very, very dark, like purple dark crystals that tasted like apple. Right, and this is all about playing with the colors and the flavors. Okay. Right now, I don't know if somebody has sent any questions through the chat or anything, or Dr. Ramos, if there's any question that you may want to ask about this, so I can start preparing the second experiment, which is also a really, really fun experiment. So we can go ahead and do it. Really quick.
So there haven't been any questions submitted just yet, but going into the chemistry of this, I know you're doing it with sugar. Are you able to do similar setups, say, with other substances like salts or anything else that crystallizes?
Well, anything that crystallizes, anything that is not soluble up to some extent into water, it's going to crystallize out. So we can do this exact same process with salt. I don't believe we're going to be able to do it with bicarbonate or like baking soda, because if we put baking soda into water, it starts decomposing. But salt, for sure, it will work. The thing is that I don't think anyone would like to try some salt crystals, right? So it would not be edible. But yes, you can definitely try all of these different types of salts. There's for example, there's a fertilizer that's copper sulfate. And you can also try it, right? Of course, you're not gonna eat it, but you can also do the same thing, and they grow, these beautiful blue crystals, natural blue crystals, right? So yes, you can try this with a lot of other substances that are around, salts. All right, so let me go ahead and start with the second experiment. So this is going to be a little bit more hands-on experiment, and this is called the can crush experiment. Okay, and the can crush experiment, it has to do with the gas laws, right? The laws of gases. And this is a beauty because all of the gases, anything that's a gas, for the most part, it follows up this specific set of laws, right? So it doesn't have to be, it's regardless of the composition of the gas, as long as it's a gas, it works. And the gas that we're going to be working with, since we're going to be doing it here at home and we have to have it available, it's going to be the gas of water or vapor, right? The warm water, when you heat up water and all of the vapor just comes out. That's the vapor that we're going to be subjecting to this chemical rules, okay? These gas laws. So what you're going to be needing is 3 cans, 3 empty soda cans. Now the volume doesn't matter, right? Since we're just doing it for fun purposes, right? We don't have to measure anything. So don't worry about the cans. There can be the tall cans, like shorter cans. There's some even smaller cans, right? Like Coca-Cola cans. You can use any can that you want. And I would try those to be, as pristine as possible. Like they're not crushed already. When you end up, or when you finish up one of your drinks, you just kind of crack it, right? Or press it. So just try to make those as pristine as possible. Okay, we're going to be using a bowl of water. Okay, this is just a bowl with tap water. Just fill up 3/4 of its capacity. We're also going to be using a pair of tongs, okay, because we're going to be grabbing these cans with the tongs, and they're going to be kind of, or a little bit warm. Okay, so the first thing that we're going to do is we're going to place a little bit of water into the can. And what is the exact amount of water? I'm just going to say a little bit of water. Okay, just very, very little water. You're not going to put that much. I'm going to show you how much I'm going to put in here. Let me see if I can just I'll just grab a normal spoon just to show you how much water. Okay, just a spoonful. That's going to work for water, right? Just a spoonful of water. Is a large, or I want to say just regular spoons. Okay, this is how much water you're going to put in here, and then you're going to heat it up on the stove. Okay, so just try to do it. I mean, the can is not going to heat up that much. The water is going to heat up to 100 degrees Celsius, and it's going to start steaming. Okay, so let me go ahead and turn off the stove, and this is going to be really, really quick. Okay, what's going to happen is that all of the water that's liquid is going to start evaporating and becoming a gas inside the can. Okay, so when I look at the can through here, I'm going to start seeing all of that steam coming out. Okay, so that steam is going to have a temperature of boiling water, which is 100 degrees Celsius. Okay, and if I get to transfer all of that steam inside the can into this bowl of water that is room temperature, let's say 25 degrees, what I'm going to do is I'm going to decrease all of the temperature from 100 degrees all the way to 25 degrees. And that's going to not only change the temperature of the gas, but it's also going to change the volume of the gas. Okay, so this gas that's occupying a volume of a total can is going to shrink, because if you decrease the temperature, you also decrease the volume, and this is one of the gas laws. Okay, so what we're going to do is I'm going to take the tongs, and when I see that there's a vapor coming out, right now there's vapor coming out. Okay, I'm going to grab it I'm going to flip my hand and grab it from the bottom, and then I'm going to really, really quick place it into the bowl of water. And by doing this, the can is just going to automatically crush. Okay, I did not press it. I can go ahead and do it again. I can do it as many times as you want, you know, and it's not good. I mean, I'm not crushing it. It just crushes itself. And why is this happening? Again, because we lower the temperature of the gas from 100 degrees to 25 degrees when I put the can inside the water that is room temperature. And by doing that, I'm also playing with the volume of the gas, right? The gas, if you decrease the temperature, the gas also decreases its volume. Okay, so from 355 mLs that this is this can, now this there's a new volume of the gas, okay? Which is, I'm just going to show you really quick, right? That's pretty much what the can is now. So if I want to find out what's the volume of this can, I can fill it up with water, you know, all the way to the top, and then transfer it into a measuring device, and that's going to tell me the new volume of the can, which is now the new volume of the gas, the water vapor that's changed because we changed the temperature. Okay, and this is a really, really simple experiment, and it's really fun. And for some people, it's kind of scary, right? Because there's a big pop that's coming out of the can, but it's completely safe, right? This is actually an implosion, so it's not exploding; it's going inside. So everything is just crashing into the one single point, right? So nothing, there's not going to be aluminum shards coming out or anything, because people think that this thing is just, you know, going everywhere, but it's imploding, it's going towards the inside. So it's completely safe. I mean, the worst thing that can happen is that you burn yourself while putting the can in the stove, right? So that's why we're using this tongs over here. So now this is room temperature or room temperature water. What if we wanted to make it? What if we wanted to crush it more, like decrease the volume even more? So if we follow Charles' law, which is the one that we're doing right now, if I decrease the temperature, the volume is also going to decrease. What will happen if instead of taking it from 100 degrees to 25 degrees, that is this bowl, I take it to 0 degrees. So if I lower the temperature even more, that's 100 degrees, 25 more degrees in the cold side, then the volume should get even smaller. Okay, and this is an experiment that we're going to do. Of course, there's some other things that we have to take in consideration, right? How much water is in there? Is it actually filling the whole can with the vapor, right? Or did all of the water evaporated and most of the vapor came out? So it's not going to crush that much. But we'll go ahead and try it, right? So we have some water. I'm just going to get rid of a little bit of water here. And I have some ice that I'm going to place inside my container just to cool it down a little bit. Okay, now I have a container that has a little bit of ice. This is going to make this colder. If you have a thermometer at home, then you can go ahead and try or test the temperature of this bowl, and you're gonna see that this is a little bit lower than room temperature. Okay, so again, we're gonna do it again. That's why we have a lot of cans. Of course, if you have 5 cans, 7 cans, then you can go ahead and do it as well as many times as you want, right? Put in a little bit of water, just a little bit, because we don't care about the liquid water. We care about the vapor water. So all of this liquid is just going to evaporate, and that's perfectly fine. Just a little bit of water in there. Let me turn on the stove. So that I'm using it, since the flame is very little, is the size of the can, it heats it up really quick. So it might take a little bit more and on your stove if you use one of the larger flames, right? Or you can also, you can also put a what's it called? A comal, right? You can just put it up and then put the cans at the top of the comal. And that also works for a lot of cans. You can do this competition, right, with your kids. Let's see who crushes the can the most. You can have them try putting a little bit more water, a little bit less water, a little bit more ice, a little bit of less ice. I had students trying to put something inside the can, right? It makes no difference at that point. But the important thing, or the key step, is seeing that there's steam coming out. So if there's steam coming out, that means that everything is evaporated already. Okay, so let me go ahead and take the can, and I'm just gonna crush it into the ice. And I think I let this can evaporate a little bit longer than I should have, or I didn't put enough water, so I don't think it crushed that much. But still, I'm gonna show it to you. in theory, it should be more crushed than the first one, right? And we're not gonna find out unless we measure it. And unfortunately, I don't have a precise enough measuring device. So we're not gonna be able to see if these two are, which one has a smaller volume, right? Which one crushed more. And the only difference between this and the larger cans is that the pop is louder, right? So you have a louder pop. You take one of those long cans, and you can go ahead and the Arizona tea cans, and you can go ahead and try those, right? Or what's it called, a michelada, Corona michelada can, right? Like they're like this or whatever. Okay. So I have a third can, and how can we make this can to crush even more? And I always tell my students to make a thought experiment. How would you make this crush even more, or crush even more with the things that we have? So the idea is to have something that not only reaches 100 degrees, but something that evaporates even higher, with a higher boiling point, and then cool it down even further. Instead of taking it to 0 degrees, you can take it to -5 degrees or -10 degrees. So for example, if you put a bowl of acetone and then you put a dry ice in there, you're gonna put enough dry ice in there, the temperature is gonna reach -80 degrees or so. I don't really know the number exactly, but it's a far colder temperature, right? And if I get to put some solvent like toluene, right? That's an industrial solvent, and this is going to evaporate above 100 degrees. So it means I'm gonna take a vapor in here that's 110, 120 degrees. Then I'm going to cool it down to -80. So these cans should crush even more. Okay, of course we're doing it at home. That's just a little bit of science. But if you wanted that can to crush even more, bump up the temperature, find out something that evaporates at a higher temperature than 100 degrees, and cool it down to even lower degrees than 0 degrees Celsius. Okay. So these are pretty much two of the experiments. So we can go ahead and think about more experiments to do at home. And later on, we can do a second session and talk about some other science projects or science experiments that we can do at home. They're really, really safe. They're really fun. And they're just beautiful experiments to talk about a little bit of chemistry. So I would like to thank you, Dr. Ramos, and thank Talbot University for inviting me to give this talk or this demonstration in here. I'm open for questions. If somebody has sent any questions, or if someone who's watching has any questions, you can go ahead and ask those. I'm more than willing and more than happy to answer them. Thank you very much.
Thank you so much, Mr. Castillo. Would you mind sharing your contact information in case there's students who want to reach out to you for kind of further explanations or even more ideas for some of these experiments they can do at home?
Email is ecastillo@southwestuniversity.edu. That's my email. That's the best way to contact me. And I also have a YouTube channel where I'm putting up all of this. Somebody's ringing the doorbell for some reason. How convenient. Give me a second. So you can reach at me on the email, and you can also send me a message on my YouTube channel. I have a YouTube channel. It's called Math from Immortal, and there's a lot of math videos in there, and I have some chemistry videos, especially for this can crush experiment. So you can always send me a message in there as well. But I want to say the email is the best way to contact.
All right, thank you very much. So I don't think we have any other questions, but thank you for taking the time and setting this up to show us these interesting experiments. Again, they're very fun to do. I know I've done them before, and they're very easy to set up and do at home. But thank you for running us through this, Mr. Castillo, and taking the time.
Invitation, and let's keep rocking, right?
Yeah. All right, but yeah, definitely check out Mr. Castillo's YouTube page. It was Math from Immortal. I know he has a bunch of algebra tutorials on there, and he's adding the chemistry stuff there. So it's a great resource for current students. And I know if students are taking his classes, they've seen those videos. But thank you again, Mr. Castillo. Thank you, everybody who joined us. But this will be it for this presentation. We'll have further presentations in the future, so keep an eye out on SU Learning for those announcements. And we'll post this recording on the SU Learning support YouTube page sometime in the near future. But thank you again, Mr. Castillo. Thank you everybody for joining us. Everybody have a great day.